Hello everyone, this is Nitin, and this video is to get the knowledge about LZ77 dictionary method. Now this LZ77 is an adaptive dictionary method. This is dictionary method because in this method encoding process do not need any statistics of the source. If you consider Huffman or arithmetic, in this method we require the probability of every symbol before performing the any process. So this adaptive dictionary is different. Here we don't require the probability of the symbol or the source. Now this LZ, the name is given after the initials of Lemper and J, who invented this method. And in LZ77 approach, the dictionary is simply a portion of previously encoded sequence. Now the encoding process. Here the encoder examine input sequence to the sliding window as shown below. Now if you look at this window is divided into two different parts. This blue part is known as a look ahead buffer, and this pink part is known as a surge buffer. Now look here, this tree diagram gives the in very detail about the window and its contents. So in the look ahead buffer, it contains only the next portion of the sequence. It means what? The alphabet from the sequence, those are not encoded yet, they are placed in the look ahead buffer. And the surge buffer, here it contains the recently encoded sequence. That means the alphabets which are encoded successfully, these are placed in the surge buffer. Now the encoding process, here the output contains three different fields. Okay, the first we find out a match in the surge buffer for the very first symbol in look ahead buffer, and the distance between the match symbol and the first symbol in look ahead buffer is called offset, which is denoted by O. The second thing is we examine next consecutive symbol or symbols in the surge buffer that match with the next consecutive symbol or symbols in look ahead buffer, and the number of symbols matched is called length of match, and it is denoted by L. The encoder searches the surge buffer for the longest match and encoded it with the triple. So the output of the LZ77, it is in this format. It consists of three fields. First is O, which is offset, which is nothing but the distance between the match symbol and the first symbol in look ahead buffer. Second is L, which is nothing but length of match, means how many symbols are matched from search and look ahead buffer. And third one is C, where the C is what? It is a code word that corresponds to the symbol in look ahead buffer that follows the match. Okay, so to get the clear what the concept is, we go through a very simple example. In this example, source is given having the 5 alphabet A, B, C, D and R, and the sequence is given like this. Okay, and the things given is what? The length of window is given here, which is equal to 13, and the size of look ahead buffer, it is equal to 6. It means that this integer represent the total number of alphabet that will be in the window at the time of process. At any stage of the process is 13. So only 13 alphabet can fit in this window. Out of this 13, the only 6 alphabet can be can reside in the look ahead buffer, and the remaining 7 can reside in the surge buffer. Okay, now the next step is what? We have to find the match for the very first alphabet in look ahead buffer, that is D. So by observing this window, actually the window is a given data. Okay, look at the last sentence is the current content of the window is as follow, means this data is given in the numeric also. Okay, so I haven't assumed this data. So now depend on the given content, we have to start the processing. Now in the answer part, the very first thing that we have to find the match for the very first alphabet in look ahead buffer, that is D. Now by observing the surge buffer, so there is no entry of the D in surge buffer, therefore the offset, it means distance between the matched symbol in surge and the very first symbol in look ahead buffer, it is 0. As the offset is 0, always the length of match is again 0. The remaining thing is what? The code word of D. Okay, if there is no match found for this D in the search buffer, then these two fields become always 0, and the third field is nothing but the code word of D. After transmitting or after doing this process, we get the 0000C and the code word of D. Now we have to update this window, but before updating the window, we have to make sure that how many alphabets we have encoded successfully. So we get the number of alphabet that are encoded from this stripper. So this is 0, length of match is 0, and the code word of D. It means that only one alphabet is encoded here. Therefore this window will move to the right by only one place, and updated window will look like this. Look here, this D, its entry is made in the search buffer now, and this very first symbol in search buffer, that is C, now it is not present in the search buffer because the size of search buffer is only 7. It can keep only the 7 alphabet. Similarly here, these 5 alphabets, they are shifted. Okay, and this R, it is a new entry made in the search buffer, sorry, the lookup buffer, and this R come from this sequence. Okay, now the one thing is remaining that I forget to tell you, that in this window the search buffer is actually known as the dictionary, because we are using the alphabet in the search buffer as a reference for the processing the alphabet in lookup buffer. Therefore the search buffer is nothing but the dictionary in the LZ77 method. Now the next step is I am taking the same window here. Okay, now the next step, the very first alphabet in lookup buffer is A. Okay, now for the A, we get total 3 matches, one here, second here, and third one is here. Okay, now in this case, how to get the which match we have to select as output. Okay, so first we go through this. Look here, we have the 3 matches for A. Very first is at offset 2 having the length 1, second at offset 4 having the length 1, third at offset 7 having the length 4. Now from where I get this data, 2 1 4 1 7 4, etc, etc. Okay, now look here, this A and this A, the distance between these two A is 2. Okay, that's why the offset is 2. And look here, this A is matched with this A. Then the next alphabet in the search buffer is D. It do not match with the next alphabet in lookup buffer, that is B. Therefore only one alphabet is matched here. Therefore for the offset 2, length of match is 1. Same here, at offset 4 we match this A with this. Now the C, it do not match with the B, therefore the length of match equal to 1. And the last one is, okay, this is a different case. Here we have the length of match 4. Okay, so this A match with this B match with this R with this R, and this A with this A. Okay, so total 4 alphabets are matched, therefore length of match it is equal to 4. Okay, sorry. After this, the output triple is like this, having the offset 7, length of match equal to 4. Okay, so the next alphabet that follow this match is R. Therefore the third field is code word of R. So the output triple or the transmitted triple is like 7, 4, code word of R. So total 5 alphabets are encoded, therefore updated window will be look like this. So these entry of these 5 alphabet are made in the search buffer. Okay, and this R will come here, and these 5 alphabets will come from the sequence. Okay, now again, look here, for this R we have the 2 different matches. Very first is at offset 1 and length of match 1, which is this R match with R. Now look at the second, at offset 3 we have the length of match equal to 5. At offset 3 the length of match equal to 5. Now one may ask me the question that we have the offset is 3 and the search buffer. Okay, in the search buffer if we match this R with this R, okay, this is the first match, this A with this second match, this r with this r, it is a third match. So maximum length of match, it should be 3, but in the answer part, look here, I write here length of match equal to 5. Okay, so how I get this 5? Read this sentence. We can extend search for the match in the look at buffer. Okay, now what is the meaning of this sentence? Just look here the next slides. This is my first match, this is second match, this one is third match. Okay, now we do not stop here, we again go on continuing the checking for the matches. So okay, I get here the another match, these are matched with this R, and this is the valid step. Again this A, it matched with this A, which is again a valid step. Okay, then these are it is not matched with the D, therefore we have to stop here. So at the offset tree, total 5 numbers of alphabet are matched, and my output triple is like this: 3, 5, and the alphabet which follow the match is D, therefore code word of D. So here in total 6 alphabet are encoded, therefore the updated window is look like this, and as D is the last symbol in the sequence, therefore we don't have any alphabet to make entry in the look at buffer, and here we stop. I hope you get the concept. To clear the concept, I will make another video. Thank you for the watching the video.